from the video you just watched on YouTube, you can see a boy pulling a vehicle, right? Pulling a vehicle with an angle, right? So that video summarizes what we are going to learn today, which is resolution of vectors under scalars and vector quantity, okay? Alright, under scalars and vectors. Alright, so if you check the simulation I sent to you, you can use it to practice most of these things I'm going to explain. You can use it to check it how it feels. I sent it already, okay? Alright, so today we are going to talk on the topic resolution of vectors into components. Resolution of vectors, okay? In components. Resolution of vectors in components. Alright, so from what we know about vector simply means a quantity that has magnitude and direction. A quantity that has magnitude and direction. And from the previous classes we have been resolving, we have been able to work on vectors, but today we are going to resolve vectors that are into components, okay? So we'll start from a simple thing, a simple illustration like this. This is a vector, then we have something like this. So you can call this one vector resultant, then you call this one vector in S direction, which is the horizontal one, then you call this one vector in Y direction, which is the vertical one. Then it has an angle here, we call it theta. Having an angle, we call it theta. So we want to resolve these vectors into components, okay? Right. Now, I will tell you the reason why we resolve it into components, but for now, let's start. Resolving this into components, we have to use an acronym known as SOHCAHTOA, okay? Which you can change to look like this: sine opposite over hypotenuse, cos, which is cos theta, adjacent over hypotenuse, and tan, which is what? Opposite over adjacent. So these are the key things you will use to resolve the vectors. Know it is an acronym, okay? Now, in resolving this now, I want to resolve this. So I will check among this SOHCAHTOA the one that will be able to get this man and this man. So it seems that I'm interested in two things like this, okay? So I want to bring it down like this, bring it so that they can be on the same side. Remember, vector is something that has magnitude and direction. So I want to make these two things like this to be in the same direction, okay? Then after that, I will still make it to be in the other direction. So making these two men to be in the same direction, I check among this acronym, the one that will meet this and meet this one. So in that case, I'll check this. Which of them will meet? You can check from what we have here. It is this one that will go, which is cos of theta. Cos adjacent over hypotenuse. Which one is adjacent? Fs. F of s over hypotenuse, which is what? F of r. Okay? So having noted that, now if you now want to get your f of s, which is you want to resolve it in the horizontal aspect. So f of s crossing over will now be f of s is equals to what? F of r cos theta. Okay? So that means I have resolved horizontally. Now, to resolve this way, I have to check among this acronym, the one that will hit only this man and this man, like trying to bring it together. Okay? Alright. Though we have many ways of resolving vector, but for the sake of this class, I don't want to bore you with too much complex strategies or alternatives. So I will just give you a simple way. Though you can use cos here and you can use cos here, but let's not go there for today, okay? Now what we'll do is that we have to look at this angle. See, there is angle here, and that is where we have angle. So we look for a way to use this angle to get these two men here. So how do we do it? We now check among this acronym, the one that will hit these two men going this way. Remember, we have something like this. Then we have something like this. So this place and this place are equal and opposite. So this place is also f of y, just like this place is also f of x. Okay? So in resolving this way, so I'll go through this way. I'll look among them, the one that will hit this one and hit this one. The one that made it is sine theta. Sine theta is what? So opposite, which is this man, which is also this man. F of y, opposite, so opposite over hypotenuse, opposite, which is this, all over hypotenuse. So it means that I have gotten this and this. So it seems I have brought them together. Okay? So now opposite over hypotenuse, the hypotenuse is f of r. So we can now have this, which is what? F of y is equals to what? If you cross multiply, you now see it is f of r sine theta. Okay? So you can see that we have f of s and f of y to be all this. So look carefully. All we have to do here is when we are resolving, you can simply put, I will tell you, okay, let me now come first. Before then now, you can now think or imagine a situation like this thing you see here now. As you see this thing here now, we have been able to resolve it. It means that when I'm bringing it down, as I'm resolving with cos, the one I did here, it seems that I take half of this thing to bring it to this way. It remains the half of it also. So when I resolve here, it seems I have taken the other half to bring it this way. It will now look like this. Okay? I've brought here, I've brought here. So for that vector to now have a particular direction, like I told you, you can now choose, though in component it has ended at this point. But if you want to know what you are doing, to that vector, to know that it's a vector, which is something that has magnitude and direction, it must have a particular direction. So in that regard, if you want to, you can use what we call what? You can use this equation, which is c square Pythagoras theorem, c square equals to, no, let me use this way. When it is like this, so it means that you can take this man here this way. Like this man, you know it has an angle. You can take him this way, it will not be like this. So it will not be like this, okay? So the resolution, which is this man, we already know, is not like this. So it means that this is our f of r. Then this place remains our what? F of y, just like I told you this side, okay? Then this place remains our f of s, okay? Then with the angle theta. So if you want to now know that this is really a vector, it has one single direction after we have resolved it, because what we are trying to find out is to know, assuming this is just like a ball or something like an object which exploded and it took a part. So when it took a part, you want to know the forces that acted on it for it to take a part, like I told you now, okay? It means that the thing that moved this way, you want to know the particular way it moves. So in this case now, check this man now. If there is a particular blade line, maybe to take this direction, that's what we are saying. So we use what we call what? Pythagoras theorem. In Pythagoras theorem, we now say f r, okay, f r squared is equals to what? If you like, fs squared plus what? Fy squared, which is what? F r is equals to square root fs squared plus what? Fy squared. So if you put the values, do it together, it will fall back to give us the real value we started with f of r if you are to know it. Don't worry, I will explain this one to you, okay? I'll show you how we come up with it. Alright, so in that regard now, we now have, let's start from where we start. So from here now, we have these two vectors, okay? Now, let's try out a particular problem, okay? In trying out that problem, before then now, we have known this, but if you want to find out if this is, I told you how to do it, you can say fr is equals to square root, this is another formula, fs squared plus what? Fy squared. This is the end of the resolution of vector in component, but this one is to confirm if it will still give us this man we started with, okay? Then if you do it, it will give you this man we started when we get a value. Alright, let's start now. A boy is pulling, let's check it this way. A boy is pulling his toy car with a rope attached. Alright, the best thing is to detect for you, like I told you. A boy is pulling his toy car with a rope attached to the toy at 30 degrees to the horizontal direction as shown below, okay? So the drawing, I've already given you the drawing before. So the drawing is just a boy which is pulling his car like this. So the angle it gave us is about what? It gave us an angle like this. This is just like the boy which is pulling the car. This is the car, okay? So it gave us an angle like this, which is what? 30 degrees. So this is boy pulling it with a force of what? 20 Newton, okay? So this is the boy, okay? Alright, so now, having done that, now you can now see that this looks exactly like what I told you last time when after resolving this vector, I now showed you that that vector can still move this way, like taking of this way, it will not be like this. It will not be this way. I told you something like that last time. So in this case now, that point pulling this thing like this. So if you look at it, it seems there is something like this, okay? So you can take this man this way. If you take it this way, it will now look like something like this, okay? With an angle 30 degrees. So this is 20, which is the resultant vector. So we have to now find this side and find this side. So finding this side as a result of what? Our resolution of vector, the way we did. Remember, I said this area is S, this area is Y. So finding this area will now be what? F what? Fs is what? F cos, if you like, Fr, if you like. But let me put it 20 cos 30. Then going this way will now be Fy, which is what? The same 20 sine 30. Whatever you press there will give us the value. So if you press it, this one will give us what? 17.3205 Newton. Okay? 3205 Newton. If you press this one, it will give us what? 10 Newton. Okay? Now, having pressed it, it means that you have been able to find only this, like using your Pythagoras theorem to find it like it is this angle. But when having find it now, we can now check that if you now find the resultant, like this 20, I know that this 20 is the resultant, but assuming you have to find resultant, which is square root of this very formula I gave you, which is f of s squared plus f of y squared, excuse me, is equals to what? F of s squared. So if you see now from what I gave you this side now, you can now see that if you put this man here, it will be 17 point, if you like 3205, you square it, and Fy squared, which is what? 10 Newton, which is 10 all squared, you now square root it. So if you press it, it will now give us what? The final distance. So if you give, or you see that if you press this thing, it will give us 20. Okay? It will give us 20. To tell you that when you do it, it will still fall back to this man. I just want to use this to clarify something. But the resolution of vector ends here. Remember, I still told you the same thing here. Okay? Alright. So now, having gotten that, I'll give you another example, very good example also, that you can check. I'll give you another example. Okay, let me do it this way. We have a nail on a vertical wall is put by means of a cord attached to its head. A nail on a vertical wall, just like this nail, is put by means of what? It's put by means of a cord attached to its head. Okay? Alright, so the drawing, I already have it there. Alright, but I will draw it for you later. I will send it to your listing. So when you are pulling it, you now see that they say a nail on a vertical wall is put by means of a cord attached to its head. If the cord makes an angle of 60 degrees to the horizontal, I'm pulling it with cord and it makes an angle of 60 degrees to the horizontal. Look at the horizontal. While this side is the vertical, okay? If it makes an angle of 60 degrees to the horizontal and it exerts a force of 80 Newton, it means that on the nails, I'm using a force of 80 Newton to pull it, but it made an angle of 60 degrees to the horizontal, which is this side, okay? Now, they say, find one, the effective force which tends to pull the nail out of the wall. Then two, the force which tends to bend the nail. So if we have something like this as a nail, okay, we have something like this. So you now have a thing like this, you have a thing like this. This is the force that tries to pull it, which is what? 80 Newton, okay? 80 Newton. Then it made an angle of what? 60 degrees to the horizontal. Look at the 60 degree here as you are trying to pull it. So they said find effective force which tends to pull the nail out of the wall. It is the force of this one, the horizontal side, that tends to pull the nail out of it. But this one tends to bend it, which is the second one, the force which tends to bend it. So this one tends to what? Bend it, okay? But two of those forces, both the one that tends to pull it and the one that tends to bend it, all of them we are able to resolve into components. This one is off here, this one is off here. At the end of the day, using the method I showed you here, they now have a particular direction they follow, which is this direction. We pull out the nail. Okay? Alright, so that's it. So in solution, we have to use what we already know, which we did before. We can use solution for the first one, force tending to pull the nail. We use, which is this one. which is Fs is equals to what? Remember what I told you, F cos 60 degrees. Simple. When you press it, it will give us what? Which is F cos 60. Remember that F is what? Okay, let me put it 80 cos 60. If you now press it, it will give us what? 40 Newton. So the one that tends to pull it out is 40. Then Fy is equal to what? You use the same thing, 80 sine 60, which is what? 80 sine 60 will give us what? 69.28 Newton. Okay? 69.28 Newton. So, but if you want to know, because I told you that the force it was using to pull it was 80, if you want to know if these two answers are correct, you can use your Pythagorean theorem, which I told you. Okay? Using your Pythagorean theorem, which is Fr squared, or Fr is equal to square root of f of s squared plus f of y squared. So in that case, now putting this man there, you now have what? You now have square root of 40 squared plus what? 69.28 all squared. Okay? All squared. So if you press it, it will give you back this 80. Press it now, you see. Okay? Alright, so that's the second